Hello, ladies and gentlemen. I hope you're all doing quite well. We're going to start another math contest, the 2015 Manitoba Math Contest, or MMC as I'm fond of calling them. So, if you'd like a copy of this contest, click the link in the description, grab yourself a pen and paper, and you feel free to try it ahead of time, and then you can watch as I go through it question by question in each video. There's 10 questions in total, which is something we should be aware of with any contest that we're going to write. That helps us budget our time if we know how many questions, where the difficult ones will likely lie. And like most contests, this one is set up so that it increases in difficulty, with question 10 being supposedly the most hard question on the contest. Okay, so let's have a look at this. The 2015 paper. It's for students in grade 12, so if you're thinking about writing this one in a couple years, this is a great way to practice, downloading a copy of the contest and trying it for yourself. You can also get other copies with the second link in my description. It's 2 hours long, which is a little shorter than its counterpart, the Euclid contest, but both of them are written questions. However, unlike most Waterloo contests, calculators are not allowed here. But we still need to justify everything, and that's going to be important. So, as I said, we're going to do one question per video. In this video, we're just going to do question 1, and then we're going to move on 2, 3, and so on, all the way down to questions 8, 9, and 10. 10 looks interesting. It's got some factorial stuff in it, but we'll get there when we get there. So, question 1, we got 2 parts to work with here. 1a, solve for x, and we have a nice little equation here. Well, let's copy that down into our notepad. Okay, so it was 5 over x minus it's over 3x, as I recall, equals 3, I think was what I saw, and plus 2x on the top there. Okay. So we have an equation here. I think the easiest thing to do is get rid of the fraction stuff. So I'm going to multiply by 3x on both sides. So 3 times 3x, we're going to get 9x here. The 3x here, we're just going to get minus 7 plus 2x, because the whole denominator is 3x. And here, the 3x, the x's will cancel on top. We'll be left with 3 times 5, 15. Okay. So now, it's very important that we put the brackets here, because if you had just done, you might accidentally do 15 minus 7 plus 2x, and that could get you a very different answer. It's minus the whole thing, which is why you might even want to, instead of multiplying by 3x, just get a common denominator of 3x on the bottom on the left-hand side. However you want to do it, 15 minus 7 minus 2x, because the minus sign distributes. Okay. We'll get 15 minus 7 is 8. And we're going to bring the 2x over to the other side. We'll get 11x. So x is just going to be 8 divided by 11. Okay. So if we wanted to, we could plug that in and double check that that does work. Now, we can't plug it in with a calculator because, again, no calculators allowed. But that's not a serious problem. It's not that hard to see. We've done our calculations properly. So, on to B part. Find the ratio of x to y, given that x minus y over x plus y is 2 over 5. Okay. So find the ratio of x to y. So whatever x is, we're going to write that down, then we're going to have a colon in between them, and then whatever y is, and then if there's common factors, we'll reduce that sort of stuff. But x minus y over x plus y. So again, we've got fractions. What I'm going to do is first copy this down. And I'm going to get rid of the fractions. So I'm going to multiply both sides by 5 times x plus y. So we'll have 5 x minus y on one side, 2 x plus y on the other side. Let's expand this out. 5x minus 5y, 2x plus 2y. And let's group everything, group all our like terms on one side. So 5x minus 2x, and then 2y plus 5y. Got to be very careful. The sign will change as we move over to the other side. Now we can simplify 3x, 7y. Okay, so 3x is equal to 7y. So, we want the ratio of x to y. Well, how many x's in how many y's? We need 3 times as many x's as we have y's. And when you have something set up like this, for example, if you had ax is equal to by, the ratio of x to y, why, it's just the constants in the reverse order, b to a. Okay. Why is that? Well, if x to y looks like b to a, and then we could find some k so that this is true. This is what being in this ratio means. You would find some k so that these are true. And then if you plug that in, you'll get abk is the same as bak, but of course that's abk as well. Okay? So that's why it works. And when you get it down to a situation like this, we swap the constants. Okay, swap the coefficients there. So 7 to 3. Okay, and could we even solve for this? I'm not entirely sure that we could. No, but what we could do is double check. Let's let k be 1. Then x would be, so this is just us checking. We don't have to. So x would be 7, y would be something like 3. 7 minus 3 over 7 plus 3 is 4 over 10. Hey, that is 2 out of 5. So we've sort of double checked our work. You don't have to. We just need that final answer of 7 to 3. But remember, we do have to justify. So we've shown our calculations. Everything is there that needs to be there. If you want to explain, if you want to give a sentence saying at the start we multiply both sides by 5 times x plus y, feel free to do so. But I would say it's clear from our work, the work that we've shown. So 7 to 3 for B and 8 over 11 for A. And those are our answers. And we look ahead to question number 2. Give that one a bit of a try, and then you can come find me by watching that video. Thank you guys for watching, and yeah, that's it. So I'll see you next time.